Welcome to this introduction to using Gephi for autosomal match analysis. If you're just getting started with analyzing your autosomal data, this is probably not the first thing you want to try. You want to start with leads or something that allows you to more simply visualize your matches, certainly. But I really think this tool can be a powerful way to look at thousands of matches all together in a nice visualization. It allows you to look at it in different ways and integrate other things that you've worked on for your matches. And I wanted to give you an introduction here to it so that you could take a look at it as well if you think it would help you. And hopefully, out of the things that I tell you here, you'll be able to extend that and find other ways to be able to make this useful. Very simply, what the tool does is it visualizes all of your matches as nodes in a network, and the connections between them are the matches that you have that also match each other. So it puts all this together in a very nice network diagram. It allows you to drill down into them, color code them, label them with different ways, and sort through them in clusters a lot like a leads method would, but in a visual way that really integrates thousands of matches together and allows you to look at it in different ways, sort through it, split it out, and take a look at the details of the individual clusters and really gain a lot of insight from each one of them. And it also produces nice pictures that you can share with your family or other people in order to explain what you're seeing. So why would you want to do this? What's the point? Well, I've got about 4 reasons why I think this is a fun and easy way to look at your matches. For one thing, it's an additional tool. It's not a replacement for anything that you're already doing. It adds to it. It helps you increase your knowledge about your matches. It also gives you the ability to very quickly organize and play with thousands of matches. If you're like me, I have 35,000 different matches in the largest of my match databases. It lets me categorize them, see different views on them. I can get additional insight into them. And it's a quick way for me to find the matches that I really want to follow up with and see if I can connect with them. It also gives me a nice visual. I can share it with my family. I can explain it to people. It helps get complex ideas across. And it also lets me look at various relationships in a visual way. I'm a visual person anyway, so that helps me as well. And it can be adapted. It can be integrated with a lot of other analyses. So you can add to this, and I'll show you a couple of ways of doing that. But you can add what you already know about the common ancestors of your matches. You can add leads, you can add chromosome segment analysis, you can add lots of other data to this and use that to sort through the matches and find new insight from them. So it really gives you a lot of power, and I think it's a nice addition to our toolkit for the analysis of autosomal DNA matches. Now, the Gephi tool itself is freely available on the web. It's a free product. You can download it. It's available for both Mac and Windows, but also being a free product, it has some quirks. It's very difficult to install and use, so I will warn you up front that you may spend a little while getting it to work. You have to know whether you have an x64 or 32-bit machine. You have to have the right version of Java, which is not always easy to find. It's all freely available on the web. You just have to fiddle with it some in order to get it to work. That's all. There is a lot of support if you search the web for various error messages and so on. But just be aware that you may have to work at it a little bit in order to get Gephi to work. It's also very resource hungry. I originally had it installed on an 8 gig RAM machine, and it was very slow. I have a 32 gig machine now, and it is still slow at times. So just be aware that it may take some time for you to get it to work. Now, if that's not worth it for you, there is a service offered by Shelley Crawford. She has a website called Connected DNA, and if she's still offering the service, she runs these analyses for people. So if you contact her, she may be able to get you started on what data would help her to produce these for you, and she may be able to produce these. So I'll throw a shout out for Shelley because she does put a lot of work into this, and she was one of the original people who did this kind of analysis. Now, I promise we'll get to the pictures and the tools soon enough, but because the data is so important to this whole exercise, I wanted to spend a little bit of time talking about what you need to get started, how you get the data, where it's from, and what the data really looks like so that you understand what it is you'll be seeing when we get to the tool. Now, as far as data goes, the minimum you need to make this useful is 2 files. There's one that's just a list of matches that starts with a header called ID. The headers make it easier to import into Gephi. And the second is a set of matches. So these are all your matches and who else they match in the testing database. And these are headed source and target. And at an absolute minimum, that's all you really need to make this work. Now, obviously, there's other information that we're going to add on here. Shared centimorgans is useful with all these matches. There's other data that I'll show you that's very useful to add as well. And in terms of number of matches, it doesn't really matter how many you have. So this is useful, obviously, mostly when you've gone beyond the number of matches that you can usefully do an auto-clustering or a leads method analysis. You can't investigate them all individually. You're trying to prioritize them. So the examples I'll show you have tens of thousands of matches in them, because that's the scale at which this really becomes powerful. But you could do this with 10 matches if you want to. It's just that the network that you see isn't going to look a lot like what we're going to see here. And those you would probably have already looked at through other methods. You could do those by hand. But if you're going to get these files with thousands of matches in them, you're going to have to get them from somewhere. So let's talk about where you get these from. I'm just keeping track here that you need two files, one with a column of matches and the other one with the match connections, the in common with information. Now you can get these automatically from the DNA GEDCOM tool if you've been able to download your information from the testing companies, because not all of the terms of services allow that. Ancestry, for instance, does not, or does not now allow it. So if you can't get the information from an automated method, you can get it from a cluster assessment. You can use DNA Painter, Genetic Affairs, or DNA GEDCOM for that. There's also an excellent tutorial by Britt Nicholson on his blog post, as noted here, that describes how to get the information manually from GEDmatch. Or you can also build them manually yourself from Ancestry DNA, 23andMe, or any of the other companies that allow you to look at the reports of who your matches also share matches with. Now, of course, building it by hand is not as easy as getting it automated. It's certainly not for thousands of matches, but you can build a different set of this information from different companies and run them individually. You can also put it all together if you want to, as long as you have information about the matches between companies as well, because you don't want to have your data artificially cut in the middle by not knowing which matches across companies connect with others. So it's easiest to run this on a single company's match set, because those are the ones that you're going to have the in common with information most often. But you can build this manually if you want to, and as I said, you can run this with any number of matches. I'm going to show you here an old file that I have that has 31,000 matches in it, just to show you the scale when you do have lots of data, but you can run this with any number of matches you want to. For this demo, I have a very old file that I got from DNA GEDCOM a while back that has 31,768 matches in it that I'm going to use for this demo purpose. So I'm using, from an ID standpoint, I'm using the key because some of my matches had the same name. But for purposes of this demo, I've gone through and changed all of my match names to just match number whatever, just for privacy reasons. Now, the good thing about this file is that it has the shared centimorgans column. We'll talk about why that's useful in a few minutes. And then I've added actually two columns here that I want to talk about. So the first column over here on the right, I've called the CLM clusters. And that is cluster information that I got out of doing an automated clustering, Collins lead method clustering from DNA GEDCOM. And so I've got all this cluster information for these matches, and I've taken these different cluster numbers and I've put them back into the data and here as these clusters, and I'll show you how that is reflected in the picture from Gephi in a minute. The other thing I have is line information, and this marks, I have about probably 250 of these 31,000 matches that I know who our common ancestors were. I've done that research. So I've mapped that knowledge in here. Obviously, as you add to this, you can add more knowledge into the file and get constant new insights into this data. But I'll show you this format and why I use it. It'll be reflected in the output file, and it's actually a very helpful format. So I wanted to leave you with this because it's a little tip that I have for how to get more value out of this data and how to actually introduce the common ancestor information into your clusters. So what does this labeling mean? So to explain this, I'll start with a very simple picture of your ancestors. Now, you're at the bottom, your father, mother, grandparents, great-grandparents, and obviously going back in time, all of your ancestors are represented by these little gray circles. So now I just start by numbering them. So your father is 1, your mother is 2. Going back in time, each generation gets another number, and the fathers are always 1 and the mothers are always 2. So On your father's side, his father is 1, 1, his mother is 1, 2. When you go back another generation, their father is 1, 1, 1, their mother is 1, 1, 2. So each labeling keeps track of the number of generations back from you, as well as the number of male and female ancestors on that line. Now, when you add a match, if that match connects up, let's say, to my grandfather on my mother's side's parents, so they descend from another sibling of my maternal grandfather, then that was 211 and 212 as the common ancestors. So over here, I label this match as 211/2. Now, it seems complicated, but I'll show you in a minute why that's actually a very powerful way of looking at the information in a cluster and see where they're likely related to you and on which line that cluster belongs. So what I've done from there is for all my ancestors here, I've gone through each generation and I've put this label, even if I don't know who they were, I've put the label against them so that when I figure out the common ancestors, and here's my other table of matches, and of course I've actually garbled these names for privacy reasons, but I keep track of, and I've got about probably 250 that correlate with this particular file, and I keep track, so obviously that's a sibling and that's a first cousin, and these are all second cousins, and then so on and so forth back in generations, and I keep track for each of these matches who their common ancestors with me are. And then I put that back into the file that I have of match data using an Excel macro to line up with the names of the matches so that I can keep track of who the common ancestors of those individual matches are. And just for completeness to show you this as well, the second file that I have is the keys that I used in the first match file, and then the match IDs are the names of all these matches. And this is just a simple in common with file that for every match I have in the database, it tells me who else they also share matches with. Again, I've randomized the names for privacy reasons. I've called them match 1 through 31,758, but you get the idea that this is just a cross-reference that allows me to draw the lines between all the nodes in my eventual diagram. Finally, now that we have this data, let's try running it through Gephi and see what we get. So I've opened up the Gephi tool. I'm going to start with a new project. I haven't done that yet, so it's completely blank. I just wanted to give you an idea of the layout of the tool before we start. Now, I'm not going to go through all the math behind all the options here. You can read about that if you're really interested. I'm really just intending to show you how to use this to analyze your matches, so I'm going to skip over an awful lot of the math behind this. I'm also not going to give you a full overview of the tool, just what I've found to be important, and if you want to look into other things, you can certainly do that. But the basic idea is you've got the graph here that's going to show you the picture of what the data looks like. Behind that, you've got a data table that we'll see in a minute that has all the data in it, so you can see the columns and the information itself. On the left, you've got an appearance box that will allow you to modify colors and size of nodes and edges and things. We'll get to all that. We'll use at least one of the layouts, but there are several that you can use in order to stretch the data, show clusters. We'll have fun with that in a second. Over here, you've got information about the nodes and edges that we'll see, and then you've got statistics that allow you to run statistics on the network to get information out. The one that we'll use in particular is modularity. And then you've got various filters that when we get to it, there will be some filters that allow us to sort the data, cut down on the data we see, and manipulate it in different ways in order to see parts of the network that are important. So that's just a very general overview. I'm going to go quickly through some of these options. If you don't catch something or you want to go back over the video to catch it, you can do that fairly easily. So bear with me as I fly through some of these things, but hopefully it'll give you a good introduction to at least getting started with the tool. Well, so we'll start by creating a new project. It just opens up all the fields, gives us some basic filters and so on. Now we'll import our spreadsheets. So we go to import spreadsheet. We'll do them one by one. Scroll over to find my matches first. So that's this one here for Gephi. Now it's already set up with IDs, so all I have to do is click next. Doesn't matter which of the other columns I import. I'm going to import them all. I'm only going to use some of them, but at least for now, I can say finish. Now the two important things here are, one, I'm going to create an undirected graph, and then I'm going to append it to the existing workspace. And you can see there's 31,758 nodes that it has found in the file. I say OK, and it pulls them all in for me. Now, I'm now going to go straight in. Oh, and if I look at the graph, it's just an unformed set of nodes in a rough square shape. There's no real form to it at all yet, and there's no color. Now I'm going to go in and import the edges, which is the in common with information. So that, I go over here, I find the in common with for Gephi. Now these are all CSV files. I've saved them from Excel into .csv files, which allows them to be imported into Gephi. So that's this next. The match ID and the in common with I'm going to take along with it. Say finish. Again, they're undirected graphs, and I'm going to append to the existing workspace. Now it says how many nodes. It says there's 118,000 that connect 12,000 nodes, but when it pulls them in, it's going to change that a little bit. And now I still have my 31,758 nodes, and there are almost 60,000 connections between them. So now, again, just doesn't look like much here. It's a bit formless, not going to get a lot of information out of that. My first port of call is I'll go over here to the layouts. And there's a lot of different ones that you can play with. And since everyone's data is going to look a little bit different, you might want to choose a different one. The ones that I found useful, there are some that are useful like the Yifan Hu and proportional. Fruchterman Rheingold works pretty well. But the best one I've found is Force Atlas 2. Now you can play with some of these. I'm not going to go into all of the details of the various options. I'm just going to run it for this demo. There's some files that I've found where some of these will matter, especially to pull out the information and look at it in more detail. But for now, I'm just going to show you what happens when I run one of these layouts. So it takes all of these nodes and it runs it, and it says, I have clusters. And without colors, now I can, if I use the scroll bar, I can scroll out of this data. And you notice that I can also use the right mouse to move it around. So you notice that there's a center part that has a lot of connected nodes. And then you've got the unconnected nodes, the unconnected matches that end up in a circle around it. Now this will run constantly or pretty constantly, and it'll get to a point where it's not changing much like now. So I'm going to stop it here. And again, I'm going to zoom in and out quite a bit on this data. It's not even colored yet, but I can already see that there's a lot of different clusters that have formed in this data. So let me pause for a minute and talk about why we have clusters at all. Why does this data naturally fall into clusters? So for that explanation, I'm going to go back to this chart of your ancestries, the simplified chart of your ancestries. And I've added here these hashed nodes, which are your siblings of your own ancestors that your matches are going to descend from. So if I take a look at your typical match set, you've got these other connections, these other descendant lines down to your matches that are represented by these blue diamonds. And as you get DNA from these ancestors, they also get DNA from these ancestors, and you get certain lines. These guys descend from this ancestor, and they share DNA from this line, and this descendant also gets the same DNA from there, obviously less, but still gets DNA, and you get a piece as well. So these matches at various distances from you along certain ancestral lines, as you know, will share DNA with you, and that's why they match you. Now, if I change the picture, I'm going to look at your ancestors as a radiograph. So this is you in the center, this little black dot. Your parents on either side, your grandparents here, great-grandparents, great-great-grandparents going all the way out. This shows 7 generations. Obviously, it goes a lot farther. So if I add those matches, now these are current-day matches in a simplified form. So the blue lines obviously represent their descent all the way down to present day from siblings of your own ancestors. But if I look at them as matches that hang off this radial chart of your own ancestry, they look like what I usually call a broccoli spear type of a network. Now you have them in various sides. You don't really have control over what match lines have survived to present day and ended up with current descendants who have also tested. So you're somewhat at the mercy of that process, which creates a random set of matches that connect to you in any particular database. And if you look at them from a shared DNA standpoint, they tend to cluster into groups. These colors represent matches that share DNA with each other, and therefore when you do an in common with analysis, they will show up as matches to each other as well as with you. So you get these groups, and of course, because different lines have tested in different proportions, you'll get them of various sizes. You'll also see that they will come down closer to present day than others because you have people who have tested who are closer to you. And I haven't shown all of these. Obviously, when you get clusters of different colors, you have common ancestors that are closer who share DNA with both of those, and I haven't tried to color those. And then you may have a sibling who shares DNA with you as well. Now, if you don't have any endogamy in your background, or at least not much, you would expect that these clusters would naturally fall into your mother's clusters and your father's clusters and your ancestors going back in time. So if that's your mother's side, let's say, and then your father's side, you'll get those clusters will be relatively unique. And then you divide that further, and these clusters will be relatively unique because you'll have ancestors down here who share DNA with a few of these clusters. But again, with no endogamy or not much endogamy, they should be relatively separate from all the branches of your ancestry. So each generation that you go back in time, you would normally think that that would split naturally into two subnetworks. Each time you go back a generation, you'll get another two because you have two ancestors along those lines, each of which should have relatively separate sets of ancestors themselves. Now, problem is, it's not quite that simple. These clusters do cross over each other, and we'll look at a couple of reasons why. These, of course, are not unique to this kind of an analysis. They also affect auto-clustering and leads analyses and so on. You've seen these before, probably, in other situations. But the four main reasons why this network isn't cleanly divided into subnetworks and subclusters. The first one, of course, is endogamy. If you have endogamous lines, that's what these red lines show here, is that if you cross over in the clusters, there will be connections between these clusters because they share ancestors and share DNA, and therefore the matches share matches with each other. You may also have pile-up regions. If you've done auto-segmenting, any chromosomal analysis on your data, you'll find a lot of pile-up regions across all the chromosomes, which means that certain of your matches will share those pile-up regions with each other, essentially by chance or by common ancestry many, many thousands of years ago, as opposed to recent genealogy ancestry. So those don't really help you when you're trying to analyze which lines those matches descend from, because they cause connections between these clusters that tends to hide the nature of the clusters as well. They don't happen a lot, but they do happen. There are ways to deal with that. If you do segment analysis and you find pile-up regions, you can identify those matches and you can remove that information. Now, you may be removing valid matches who share DNA that way, but hopefully those will also show up on other chromosomes and you won't lose that information. But you also, your closer matches don't always help you because they also can blend, especially if there's a lot of them, like in this area. You'll find that they share DNA with a lot of the matches connected to you earlier than them, and therefore they tend to hide the fact that these are separate clusters. So one trick as you go back into generations, if you do this analysis several times, is to take out your closer common ancestors so that they don't overpower the clusters that you're trying to look at. And of course, you won't get your data naturally falling into two subclusters at every generation because it may not be balanced. Now, you almost never find an equal number of matches on both sides of your ancestry as you go back each generation, but sometimes there's almost no one who has been able to test from one line. Maybe you have a grandparent from an undertested area of the world, let's say, where you have very few matches. Even if there are a few, they don't necessarily share DNA with anyone. And I represented that in this picture. This is the same picture from before. If I go back a slide, you've got this whole quadrant here. One of my grandparents in this example comes from an area that hasn't had a lot of descendants who have tested. So although there's individuals here who have tested that I may share DNA with, they're not connected to anyone else. And if I split this network and I looked at these two separately, I would only really see one set of clusters because this is the main set of my ancestry that's giving me data as to who I share any DNA with. So you'll find this a lot, especially as you look back in time. You'll get a line that has a big cluster and a line that doesn't. you can't easily identify the line or the individual matches that you might have from a line that's under tested because you can't find a cluster to be able to connect those individual matches with. So back to my Gephi data. So I expect to see clusters. I expect to see this, what I call broccoli spear effect in my network, and I also expect that it's not going to be perfectly distinct, that there's going to be crossover, and in fact I see that in the connections between these clusters. There's quite a lot of crossover in some, and in some of them they're very distinct networks, clusters, and in some of them they're not so distinct as well. Now, the amount of clustering in a network is known as modularity, and there's a number of statistics here that add data to my information. So I'm going to use one of those, called the Modularity Filter, in order to add some color by cluster to this picture. So the first thing I'm going to do is run it. I don't use weights. I'm going to make sure that that's turned off. And my resolution I'm going to have to play with because it depends on the network and what kind of resolution is going to be effective at pulling out these clusters. So I'll start with, let's say, 12. Just to see what it looks like. Okay, now it runs, it brings me a little report, which I ignore, but if you're interested in modularity, you can see what that means, and you can look at the modularity in terms of, it did find 19,000 communities, clusters here, and that's much more granular than I need, but a lot of these fall into large groups, so I'm going to close that. Now I'm going to come up here to the appearance of the nodes, and I have options for color, options for size, options for the label color and the label size as well. And now I'm going to choose color, and it's unique at the moment, it's all black. So I'm going to choose the partition, and when I ran my statistics on modularity, it added this thing called modularity class. I can choose an attribute, I can choose a number of different attributes here that are all the columns in the actual data table that I have. I'm going to choose the modularity class, and you see how it's already populated a lot of these for me. I'm going to apply them, and now I have my clusters have some color to them. It's not quite perfect yet. I have a lot of green. These didn't get split out by this. This is a big cluster here too, and I'd like to see more detail by color here. So I'm going to run modularity again. I'm going to ask for more communities, more clusters. So I'm going to drop my number down to, let's say, 6. Then I'll run that again. It runs again, gives me a report, which I ignore. I'm going to apply this. Well, it still has a community here, and these communities don't seem to be that distinct. I don't have a good set of colors. I'll deal with that in a minute. The first thing I'm going to do is drop this down to maybe 3. See what happens there. And now that I've run this again, I have some distinction here, but my colors aren't really what I want. I don't get to see these major communities split by colors yet. So I'm going to go down here to the palette option, and I can choose different palettes if I want to, but I can also go down here and generate my own. Now I have 19,000 different communities here. I don't want that many colors, but I am going to still limit the amount of colors, but I'm going to bring this up to, let's say, 16, and then I'm generating a palette for all these. So now I've generated all these colors. When I apply that, I suddenly have a very nicely split out set of communities that are sorted by color. There's still some that are not distinct. Now, if I feel like it, I can come up here and I can individually click on these and change the individual color. Let's say that I want one to be yellow. So I move this over here, and then I apply that, and now I have that community be yellow. That's a little too bright, so I'm going to come back here and change it back to a darker color, so that's a little bit better. Again, I can play with this as much as I want to in order to get the color scheme that I want. Now, the other two things I'm going to do to make this visually more appealing is, one of them is I'm going to come over here to size. So the node sizes right now are all the same. If I zoom in on these, I have nodes that are all the same size. That's okay. Now that I have it colored, I could do some analysis here. But it's more useful if I can see these by size. And the size I'm going to pick is ranking. The attribute I'm going to pick here is shared centimorgans. Now, you can do the min and the maxes as much as you want. If I apply this, I suddenly get large sizes and small sizes that's my sibling, and these are cousins, and then it drops down into the smaller pieces. And so I get this nice scale of sizes that I can look at and analyze a little bit better. Finally, I'm going to add labels. Now for that, I have to flip over to my data table, because I have labels in this column here, and they're all blank. If I add labels now, it's not going to do anything. What I'm going to do is copy data from one column to another. So my match numbers, which normally would be the names, I'm going to copy from the match num to the labels. And now I have matches in here. And if I expand that out, of course, it's match number whatevers. So if I flip back to my graph, I can add labels. So I go down here to this little icon down here and click on that. And I say labels. I want my nodes to be labeled. So now they're all labeled. And I'm furthermore going to change the node size of the labels to match the node size of the node. Now, at this level, that's completely useless. I can't see anything. If I scroll in, you can see that these matches are in fact labeled by all my names. So if I wanted to see them by name, I can do that. And when I hover over any of these matches, they appear, so they get highlighted and I can see them better. And I can see these matches and they're all named. So if I was looking for names, if this wasn't completely privatized and I could see names here, then I could go into some of these matches and I can see all the names. This might not be terribly useful. I could sort my data. Now, the data that I originally took, this 31,000 node file, is all of my matches down to 7 centimorgans, which is pretty small. Let's say that I want to filter that, and I only want to look at the data that's, let's say, down to 20 centimorgans. So that's where I go to my filters. And that's an attribute. And it's a range, in fact. So I click on range, and I see the shared centimorgans is a range. So I highlight that, and I drag it down to my filters. And now I see that my range in my data is from 7 to 2741, which is my sibling. And I can drag this in and out, but it gets a little bit hard to set it exactly to the number I want. So let's say that I click on this and I change that to 20. So when I change that to 20, watch what happens in the graph when I apply the filter. I apply the filter and it suddenly reduces all my smaller matches down, and I can zoom in now, and it's a lot easier to see all these matches. So I've filtered it down to 20 centimorgans. And that may be the first level of analysis that I want to do on these clusters, and I want to open it up later and take a look at it in more detail down to 7 if I want to look at a particular cluster and who else is related to me. So now I really can start to do more analysis. So here's a nice cluster. I zoom in on it. I look at these names. Maybe I follow up. There's a few here that look like they have larger centimorgans with me, so I want to maybe look at match 10 in a little more detail, see they're probably a closer ancestor to me than all of these. And if I click on this little icon here on the side, which is the node attributes, that allows me to then click on a node, and I see the attributes here. So this is match 10. I already know that because that's what the label says. But if I look at this, they're related to me. Here's the exact number of centimorgans. If I scroll down here to see it, there's the exact number of shared centimorgans. I can see who they are. Maybe I can follow up on that match and see why they're connected to all these people if I can find them. As I start to analyze these clusters, though, there's an even better labeling system that I can use to gain value from this. If I go back to my data table, you remember that I have this column where the lines that I connect with, the common ancestors that I connect with these approximately 250 of these matches. Now, if I copy the data from that column into my labels, I obviously have far fewer of them. If I go back to my graph now, I start to see something interesting. I see that the clusters have a consistent set of initial ancestors. So these three, I believe, are on my mother's side at varying degrees of distance from me, varying generations to the common ancestors. My mother's father's father, in fact. So here is my mother's father and his parents. So this looks like There's only 4 of these, but this one does look like it's a closer match in terms of ancestors. So this fits the pattern that I was talking about before, where the cluster appears to be, certainly on my mother's side, but it appears to be my mother's mother's side, and even further back when I look at this. So here's one relative that's related closer to me, and then I go back a generation and I have this cluster that also connects to this. So we see the pattern that I talked about before in my broccoli spear chart. And the ones that I've investigated already tell me that this cluster is on that side of my family. Now, if I back out of here and I look at some of the other clusters, let's go over here and zoom in on this cluster. And I find this is my father's line. So this is my father's. In fact, this is my second cousin here. This is my first cousin. And I have a couple of cousins here, but here are some that are related even further back. If I look at this, it looks like it may be my father's mother's father's mother's mother's father's side at the extreme. Now, there's going to be cases where someone from another line is mixed in here just because either there's endogamy or there's a big pileup region or something's going to happen. So I have to be careful not to assume that the entire cluster is from this line. But I can add these labels to this chart and really get a sense of where these clusters come from and track back to the individual ancestors that this DNA has come down. Now, here's another one. This looks like, again, this is my father's mother's side with some level of distance past that. See, here's one, for instance, that's from my mother's side, I think. Now, I could be wrong. That's possible. But it could also be endogamy. So I have to be careful how much. But the vast majority of these certainly look like they're coming down the same place. And here's one, for instance. This looks like, it's a little hard to see, but this is a closer cousin that they have a larger amount of shared centimorgans with me, and they are sort of standing in front, so to speak, from an ancestral connection standpoint, all these other matches. So that, again, is consistent. So I'm seeing the right patterns in here. Now, I can use the information from the investigations I've already made into some of these matches to be able to help me track back on some of these other lines. Here's one cluster that I have no idea where all these people connect with me yet. I've not done any amount of research. So if I click on this one and I see who this is, I get that they're match number 42, so I would have their name normally, of course. At a 63 shared centimorgan level, they're a pretty good match. And I need to follow up on this person because they apparently are the key to finding out who all of this cluster is from. So that one I don't know yet. It's a good indication in here that this is a particularly important match to follow up on and see if I can identify their line. But this is the kind of data that I can get from here. Now, here is another match. If I zoom in on this, it appears to be from my mother's father's side. That's what these two say, and these two are sort of the gateway into this cluster. So I know the start of where this whole set probably connects to me. But again, it's worth following up more. I only have these 2 data points so far. It would be nice to confirm that for this cluster and so on. So that's a level of analysis that I can do. Now, I can easily bring this back down to 7 and go back into my clusters and see if there's any, because there are a few people that I've been able to find that are farther out, but it's a little more difficult to see in a few of these clusters. I could change the colors. Here's one set here, this green cluster. Looks like it's 2-1, my mother's side. This is on my mother's side, so I could follow up on that. My mother's father's side, in fact. I could get a little more detail out of that if I followed it up. They're not really tightly packed together, but they do seem to fit each other, so I can do a lot of research on these and really drill down to which ancestral lines they connect on, and really follow up and see if I can find a few more of these matches and connect them without having to assume that they could come from anywhere in my lines. Again, I have to be careful not to make the assumption and find out I'm wrong, but it's a good way to at least start to follow up and see if those are the lines that they in fact connect on, because it's very likely that they are. Something else I can do, if you remember, I scroll back out. if you remember, I had this extra column that I pulled in that had these clusters that I got from my Collins leads analysis. And let's say that I had done a lot of work there and I knew what these clusters were and I knew a lot about them. I can go back into my nodes, go back to my graph. I can go back to the color of my nodes and I can choose to color them by that cluster information. So let's say that I want to expand my palette as well. So I go back to generate, have 143. Let's say that I don't want to do that many, but I'll do 25 of them or so. And then, whoops, that didn't work. Go back to generate, go back up to 25 of them or so. I actually have to generate it. There we go. Okay. Now I apply that. Now, when I look in here, obviously my analysis I had done only on a subset of these matches. So when I look at all the matches down to 7 centimorgans, I have a lot more of these matches that tend to fall into these clusters. But it's a nice validation that the clusters that I see here tend to fit with the leads methods analyses of these matches as well. Now obviously these colors won't match up to what I had in my boxes from the leads analysis, but if I look at these, I can see what the individual names of these clusters were, and I can go back and cross-index them with my analysis there. But so I have a larger group here than this single cluster or the single box had given me in the leads analysis, and all these other matches probably belong in that box as well. I just didn't have the complete set of these in my chart when I did the leads analysis. So anyway, it's just a nice validation that the two equivalent ways of looking at the data do give you very similar pictures. It's just that this is a little bit of a different format, and it allows you to play with the data in a different way. Now I'm going to go back and I'm going to color these all black again because I want to go back and take a look at this set of data all the way around here, this halo of data. Now these are unconnected matches. These are matches that don't have any other connections in the database, in this network. So if I zoom in, there's no edges here. They're just all individual, usually very small connections. They share very small numbers of centimorgans with me. So I want to look at those. I probably want to eliminate them. There's not much I'm going to learn about them, but I don't want to eliminate them if they're large shared amounts of centimorgans because they would represent an ancestor that I could track down. They may be lines that I don't have very many tested matches from, and they might be important because they could break through a brick wall. So I don't want to lose them altogether, but they're not really useful for my network analysis in this way. What I'm going to do, though, is I'm going to filter down to look and see whether any of them are in the range that I want. So to do that, first of all, I'm going to see if my first range, I'm going to switch that back to 20. Now I don't see them anymore, they're all very small, but there may be some there that I just can't see in this picture. So now I'm going to go look at a different metric. So I'm going to look at the range again, but I'm going to look at the topology because that's the characteristic of the network that I've got. I'm going to choose this thing called degree range, and I'm going to make it a subfilter of my shared CM. So when I look at the degree range, I have everything from 0 to 716, which is the highest number of connections that any node has. So degree is the amount of edges that a particular node has, let's say. And I want to go back to that as 0. So if I filter this way, obviously this disappears. I see nothing because I'm only looking at the nodes that have a degree of 0 that aren't connected to anything. And now when I flip to my data table, I see there are no nodes that are in this range. I can go back to my shared CM and say, oh, okay, the highest that I have is actually a 19.9. Well, that's pretty high. So let me drop this down to 18, let's say. And now I have a whole bunch of matches here between 18 and 19 centimorgans that I can see who their names are, and I can see who they might match, or I can follow up with them and see if they can tell me who their ancestors are enough to be able to find our connection. Now, a few of them are in the clusters that I found through my leads method analysis. None of them, I notice, when I scroll down through this data, have I done some work to identify yet, so I don't know where they come from. But there's a couple dozen here that might be interesting for me. Oh, actually, when I look over here, it actually tells me that my filtering has given me 36 of them, so with 0 edges, not surprising. And these may be important or they may not. They're not 7 centimorgans, but they're not that large either, so I need to follow up and find out if they're important. But they're just another category of data that I can investigate further and see if that's important to me or not. For purposes of my demo, let's say that I've investigated them and I don't really care about them, so I want to eliminate them. So what I can do, now I can come up here and I can remove any of my filters. So I get back my data here, and let's say that I go back to remove this as well. So now I have all my data back in my view and in my data table. Now let's say that I want to remove all of these. Well, that's easy enough. I go back to my degree range by itself, drag it down here, and instead of 0, we make it 1. And I choose filter, and my halo has disappeared, and I'm down to just this one set of nodes. So now, if that's what I want, if I'm done with all the others and I really want to focus on that and I want to eliminate it, if you look up here, it's reduced my nodes in my visible space down to about 12,000. It's taken out most of them, in fact, or more than half of them. But I still have all my edges, of course, and let's say that now I want to focus on this. If I go to this little icon here, it's called Export the Filtered Graph to a new workspace. So I can export this out. I've created now a workspace 2, which has only my 12,000 nodes, and I can pick this up and work with it as a subset of my data. Now I can come up here, I actually never save the first one, but I can save this as something else. So I can save this set of data and work on it as a separate workspace and come back to it later. I can save my first set of data as well, so I can always come back to the original. But now I have a copy of my data that is focused only on those nodes that have matches. And this is, of course, where I'm going to spend most of my time because I'm going to investigate this. Now I can come back here to the appearances, go back to my colors, and partition this. I still have my modularity class, so I can apply that back again. I don't have my palette though, so I need to go back to the palette and generate a new one, and maybe do that up to, well, I have 13 colors, so I generate those. Okay, apply that, and now I have a set of data. It's different colors each time. I could, of course, go back through here. I can even save a palette if I want to make it consistent. But the fact of the colors is just that they're different. It doesn't matter really what they are. Now, I do have some data in here. Like I still have this sibling, and typically the sibling makes it a little more difficult to analyze. So I go to my data table. Now, I can filter the sibling out, of course, if I do it by shared centimorgans. Or I go to my data table because I know they're match 1, and I can simply right-click and say delete, confirm that no deletion, yes. The graph now no longer has them in it. Now, if I rerun my Force Atlas 2 with the same parameters, it's going to stretch out these clusters a little bit differently without that node that pulls things together. So it actually expands my clusters a little bit and gives me a little more insight into them. So this changes it in slight ways. Again, it's an easy way to remove a lot of the cross connections between clusters, and you can focus on the clusters a little bit better. So I can stop that, go back to my nodes, say, yes, please, I want my labels by node size, come back here, zoom in, and I'm back to my analysis by lines, by colors, so I can go find out more about these. Now, let's say that I've completed all my analysis on this, and I really want to focus on one side of my matches. So I want to focus on either my father's side or my mother's side. So what I really want to do is try to split this network in half. And it's not going to be exactly half, of course, but I'm going to try and find the clusters that belong together so that I can focus on one side or not. Again, I go back to modularity, but now I'm going to play with higher numbers to get smaller communities. So let's go back to my 12. And of course, I've changed my graph now, so these are going to be different. But I'm going to go back to my modularity and go back to modularity class and apply that filter. It's not bad. I probably want to do it a little bit more. So run this again. Bump that up to 18. I don't know why I keep doing multiples of 3 and 6, but now that's pretty good. So now I've split it approximately in half. So now I go down here and I look at this, and this is all my father's matches. This is my father's matches here too. I look over at the blue, and it's actually mostly my mother's. Looks like I've done a pretty clean, again, it's not going to be perfect, but I've done a pretty clean split into 2 approximately equal groups. And let's say that I just want to focus on my mother's matches. So I can come back to my filters. Now remember, this is modularity class. So I can either do, if I only have 2, I can do it on equal. So let's say that I want to pull out my mother, so I want the 0 ones. So I can do attributes equal, and I want the modularity class, so I'm going to pull that down and say my modularity class equals 0. So if I filter, all those matches disappear, and I'm left with only the blue ones. Again, I can export this into a new workspace, number 3. I could save that as my mother's matches. Again, I keep saying this, but it does bear repeating that this isn't going to be perfect. It's just a way to get the majority of them split out. Now, if I want to look at the amount of shared centimorgans here, I can go down to range again. I can go down to shared centimorgans, drag that down, and see that the largest I have is 168. That's pretty good. Maybe I want to start at 20, maybe I want to start at 50. I can start at anything I want to, and click filter, and now I have only a few here. And let's say that now I really want to know who these people are. So I go back to my data table, my labels, I want to copy these names again, and some match numbers, come over to labels. There's all the people. There aren't very many of them, of course, but I could apply these labels on it by node and do it by node size again. And now when I zoom in, I have a very sparse network here of just these matches, and I can go investigate them. Don't know why I would want to do that. I'm just showing you that there's different views of this data where you can filter it down to a very small number, investigate those further. I've now split this by, so now if I go back to remove this completely, if these truly are, and I'm going to turn off these labels just because it makes it a little bit busy. If I truly want to split this again, I can look at running a modularity filter just on this and say, I don't know, maybe I'll go back to 18 and see what happens. But presumably, if I go back to the color by modularity class, apply it, presumably now I start to see the same clusters, but I start to see them split by my maternal grandparents. So if I go back to slightly higher, I'll make it 22. See how that goes if I apply this. Oh, that was 100%. It's all, so that was too high. So now I'll go back to 20 and try this again, apply that. Okay, so I have 2 clusters here. So this may be one side of my family and the other, or one side of my grandparents and the other. I don't know. It's worth investigating a little bit more. I'm not sure if this is as clean at this level, and I may need to eliminate some of the closer matches in order to get a cleaner break out of these clusters. But that's one way to go look at your matches generation by generation into the past. Of course, at some level, endogamy and pile-up regions and the rest of those problems will make it impossible to go any further. But at least I can investigate some of my larger matches and remove the sides of my family that I know aren't involved, or at least aren't involved in most of these matches, and really focus on one side. So that's another way to look at the data. So the last tip here really is, if I go back to my workspace 2, workspace 1, okay, let's say that I go back to workspace 1, I apply this palette, I have these nice colors. Actually, that was by the segmentation. Let me go back to modularity class, apply this. Let's say this is a nice picture that I want to save and send to my family and show them what my analysis looks like. So if I go to preview, click refresh, it's going to generate a higher quality version of this picture. The default here are the lines are curved, so I'm going to make them straight. Refresh that data. So now if I zoom in, I have this nice, it's a little bit busier. Maybe I should filter it to get a few less, but let's say that this is the way that I want to do it. If I drag it down here to put it in the middle, then I've got my picture. So now I can either obviously copy it straight off my screen, or I can export an SVG or PDF here. I can save that as a picture, and then I have it saved off. So that's really it for an introduction video. There's obviously a lot of other things that you can do with this. You can run other clustering algorithms to weight it or to color it in different ways. You can filter it in lots of different ways with other operators on here. You can look at the topology of the network in different ways if you know something about what all these mean. Ego network, for instance, allows you to follow up a particular node and its neighbors at a certain distances away. So if you have somebody in this network that you want to see how they're connected, you can follow up in a graphical form. You can see it in the network. That's one way that you could look at them. But really, from a cluster analysis standpoint, it's a very powerful way of identifying, of using the work that you've done so far. You don't have to use this labeling convention, but I find it useful in order to see which lines these clusters come from. And it's a nice, versatile, and changeable way of looking at your data and manipulating it in different ways. You don't have to go this route, of course. Leeds method works perfectly fine, and if you don't have thousands of matches or the ability to get them into an ICW file, there's no reason why you have to go this route. But it's just another way of looking at your match data and another way that you can follow up to hopefully break through some brick walls and sort through and organize your matches. So I hope you found that useful. And if you do use Gephi, best of luck in having it help for your genealogy research. Thank you.